Okay, yes, hello Fish. Welcome on your
Yes,
YourPedia platform and let's
thank
start
you.
your Snap mock for thermodynamics and application. As you mentioned, we are preparing for some placement opportunities. We are going to get
Yes,
in
yes,
institution.
yes.
So, Fish, what is thermodynamics?
Thermodynamics means in the name itself we can define it. Therm means energy, thermo means energy, and dynamics means transformation. So how energy is transforming, we can learn in this thermodynamics. Energy means here we can say stored form of energy, energy in transit. So how these transformation happen, we are learn from this thermodynamics subject.
Energy is conserved, Fish. So, what do you understand by loss of energy? We say sometimes in a particular process we lost some energy,
Yes, sir.
but energy is conserved. We cannot create, we cannot destroy energy.
Yes, sir.
What do you mean by loss of energy?
Actually, everywhere we energy conservation of energy law is applied, but for suppose let us take a system. If you say if you say we are heat is entering into the system, so some amount of heat will be lost from the system. Actually, it is a loss from the system, but we want that total heat into the system, but it is generally not possible because the heat is low grade of energy. So every time it should loss to the surroundings only. If you finally if you take a system, if you add energy into the system and energy out to the system, if you add these things, then finally you will get conservation of energy. Suppose if you take a heat engine cycle, some amount of heat only converted into the work, some amount of energy rejected to the surroundings. So,
Okay. Since in thermodynamics we consider various kind of thermodynamic processes like constant volume, constant
yes.
pressure, constant temperature. So can you
Yes.
give me some kind of real life, kind of application or realization of these processes in our daily life?
Yes.
Mm-hmm.
Sir, can I say adiabatic process, sir?
You need to give me one example of each.
Yes, sir. Yes,
Adiabatic,
sir.
isothermal, isochoric, isobaric, holotropic.
Okay. Okay, sir. First of all, I will go with adiabatic process, sir.
Mm-hmm.
The process which is something very fast, so that suppose leakage of air from football and flow of water through some walls, all these we will consider it as adiabatic process because it is very fast, so that the heat transfer to the system will be very negligible. We can say it only adiabatic process. If it is a reversible adiabatic process, there will be no, I mean, there is no small amount of heat rejected to the surroundings,
Mm-hmm.
and constant pressure heating. Constant pressure heating, sometimes we can say pressure cooker.
Mm-hmm.
It is also constant pressure heating.
Mm-hmm.
Uh, I think there will be initially unsteady state in the pressure cooker. After that, after reaching the steady state, then we can say it as a constant pressure heating process. And also, if you boiling water something food in a closed lid, if you consider it as a closed lid, there is no heat and no mass transfer from that lid. So that type of heating we can say it as a constant volume heating. And
Mm-hmm. What about isothermal?
isothermal. I think it is not possible to, I mean, isothermal heating, we can say that we can convert the ice in solid form to liquid form. There, in that heating process, we can say that it is isothermal heating process because it will, the heat energy will tries to break the bonds in that. So I think we can say that it is an isothermal, so there is no energy out to the system.
What do you understand by polytropic process?
Sir, if you, it is a generalized process. I mean, when the polytopic index is 1 to between 1 to 1.4, in between these index, we can say it as a polytropic process. Neither it is an isothermal nor it is a adiabatic process.
Please, what is your understanding related to second law of thermodynamics?
So, what about?
What is your understanding related to second law of thermodynamics?
Second law of thermodynamics. So, second law of thermodynamics is says about the energy direction of energy. It will say that whether if you take a system, so is this energy transfer is possible. Suppose naturally we can say that water fall from hills. So energy from higher energy to lower energy always transfers from higher energy to lower energy. If we can define second law of thermodynamics by two statements, Kelvin Planck statement and Clausius statement. Kelvin Planck statement tells about us conversion of energy. Suppose if you give a work, we can convert into 100% heat energy by consideration of ideal process. But if you give heat to the system, it is impossible to convert into 100% to work. There is some amount of energy need to be transferred to the surroundings. Coming to Clausius statement, it is impossible to uh, energy flow from low energy to high energy without any external agent. Suppose if you give some work to it, so that it is possible to transfer energy from low energy to high energy. Finally, we can say that it is a law of degradation of energy.
Okay. Please, suppose we are having a rigid tank.
Yes.
Okay. And there is air inside that rigid tank. So suppose first we heated that air, okay, by providing some kind of external heat, okay, and then due to that heat addition, the pressure increases, pressure temperature increases inside the rigid container. Now, to restore the air at the same initial pressure, we leaked out some air out of the tank.
Yes, sir.
Then can you show that these two processes on a PV diagram?
Yes. While it is leaking from the container, we need to show that on the PV diagrams.
Both the process, yes, the heating process, first heating process, and the second process also you need to show, and you need to reach to the same initial condition.
Sir, this is a constant volume heating process.
Okay.
So second is while after the leakage, I mean while leakaging, we have to show in the PV diagram.
We are removing some gas out of the tank so that we will be able to restore the gas at the same initial pressure.
Is it possible? You are asking.
Yes.
Sir, I think practically it is not possible to.
Why?
Sir.
Why it is not possible? There is gas
Because
from a high.
yes, sir. Because some entropy will be there in the system, so we can't restore our initial state by leakage some amount of some pressure to outside. But ideally, we can say.
It is not possible to restore the system to the same initial condition.
I think it's not possible, sir. But yes, sir, it's possible. But we have to do some amount of work because there is some entropy will be there in the system. So we can't perfectly restore to the initial state.
नहीं restore तो कर सकते हैं, switch but you need to to say restore कर सकते हैं without affecting the system and surrounding. We cannot restore.
Yes, sir. Yes, sir.
We cannot restore the system to the same initial conditions without affecting the system and surrounding. So reversible it is not possible, but irreversible you can
But
restore by
yes,
affecting
sir.
the surrounding.
Yes,
When we are leaking some gas out, so entropy of the surrounding is going to increase.
yes, sir.
But definitely we can restore the system to the same
But
initial condition.
we have to use some energy, from amount of energy from our side.
No,
So
no,
this,
even there is no energy required, but there must be some entropy generation in that process.
okay, sir. Otherwise, it will take more time, right, sir?
No, system you are restoring to the same state, so you can consider yes, there is no change in the entropy of the system, but surrounding entropy is going to increase
Yes, sir.
because even suppose because we are not considering any kind of heat transfer to the
Yes, sir.
surrounding, rather we are taking heat from the surrounding, so the surrounding entropy is going to decrease in that case when you are
Yes,
taking heat from the surrounding.
yes,
But
sir.
finally, you are giving mass you are dumping inside the surrounding only, and
Yes,
that
sir.
mass also is going to bring some entropy into the surrounding. So net entropy change of the surrounding will be what? That will be positive. So that thing actually I thought ki I will ask you
Okay, sir.
because how you will find out the entropy change of the surrounding in this case? The entropy change of the surrounding will be Q by T, temperature of the surrounding, minus Q by T, that will be
Okay.
minus. Why it will be minus? Because you are taking heat from the surrounding.
Yes.
But the entropy which mass is bringing into the surrounding, that will be positive. And that will be mass which leaked out multiplied by the entropy of that, specific entropy of that mass.
Yes.
Are you getting this?
Yes, sir. Yes, sir.
So that net entropy change of the surrounding, that will be positive because system entropy is zero, the surrounding entropy is going to increase. So we can reverse that process. Even we can restore the system to the same initial state, but reversible it is not possible. The process
Yes.
will be irreversible. So entropy generation will be there. Fine. तो मेरे को आपने बताया कि ये जो आप अवेलेबल एनर्जी क्या होता है, व्हाट डू यू अंडरस्टैंड बाय
Uh,
अवेलेबल एनर्जी?
actually, how much amount of system, which I mean, how much amount of energy in that system, so that I mean, in that source, so that we can use a useful amount of system, like useful amount of energy. Suppose we will take, suppose we are heating uh, some gas in the piston, so it should our energy should we use some amount of energy to boundary work. I mean on that piston, some atmospheric pressure is acting, some work is acting. So that extra amount of work we have to spend from our pocket only. And also this available energy depends upon the surrounding systems also. I mean surrounding temperature, temperature and pressure also. And some irreversibility. Suppose if we are we are adding heat reversibly, so there is no problem from our side. Suppose if there is irreversibility in the system, so if you suppose we have to write some available amount of energy from our side, so from that we have to extract that boundary work and also irreversibility. The remaining work having in our pocket is called as available energy. And everywhere this boundary work will be there. We can lose it is a loss from our energy only, but irreversibility, I can we can reduce that irreversibility, but we can't reduce it to zero, but some extent we can reduce that irreversibility.
अच्छा, आपने एक एवोगैड्रो लॉ सुना है आपने? You
Sir,
heard about that?
what lesson?
You heard about Avogadro principle?
Avogadro's principles. Yes, sir. Number of moles equal to mass of the system by molecular weight of the molecules. Uh, that is directly proportional to pressure and volume, inversely proportional to temperature.
So what do you understand by irreversibility? What is irreversibility?
Irreversibility, if you are suppose there is a system, if you are eating that system, uh, when there is a temperature difference is large, so that we cannot if suppose we are adding heat to that system, and if and that while adding this heat to the system with a large temperature difference,
Mhm.
so some amount of heat will be lost, and we cannot restore that system to initial state. I mean, we cannot do that. I mean, we cannot restore that same amount of energy from that system. Suppose if you add heat to the system by finite temperature difference, so that we can say it is a reversible system. So whatever amount of energy that we cannot restore from the system back, so due to because of that some reasons like entropy and etc. So that a loss of amount of energy, we can say it as irreversibility. I mean, we can say that T into delta S, I mean change in entropy, we can say it as irreversible.
Okay, Fish, I think now I can provide you the feedback. Because Fish, overall your delivery style is looking fine. You are looking comfortable. Uh, I think you are having some confusion related to that reversibility. So reversible process. What do you understand by reversible process? A process which can be reversed in its direction without affecting the system in some way. So in a reversible process, there will be no loss of work. Energy तो conserved रहता है. There is nothing, you cannot say that there must be some energy loss. Energy loss means what? When we are saying energy loss, it means we are losing some work. Work potential we are going to lose in a real process. So work is not conserved. Heat is also not conserved. The total energy is conserved. When we say energy is conserved, we cannot create energy, we cannot destroy energy. The total energy is going to remain conserved. But in all real processes, what we are going to lose, we are going to lose the quality of energy. So loss of energy means loss of quality of energy. Loss of energy means loss of the work potential. We are going to lose the work potential. ओके तो अभी होता क्या है कि जब हम बात करते हैं इरिवर्सिबिलिटी की इरिवर्सिबिलिटी इज द मेजर ऑफ द लॉस ऑफ वर्क हाउ मच इज द वर्क पोटेंशियल यू आर हैविंग अर्लियर minus how much work we are having now. So that loss of work is going to give us irreversibility. Like for example, in a power plant, suppose for example in power plant, what you are giving? You are giving some fuel, you are burning some fuel. So that fuel is having some work potential. But the actual work which you are getting, the electricity, that is a different work.
Yes.
The difference of that is what? That is the irreversibility.
Okay.
Similarly, in a hydropower plant, the water which is stored in the dam, it is having some work potential, MGH.
Yes.
But the work which you are getting on the generator, that is different. And the difference of that is what? Again, it is the irreversibility.
Irreversibility.
Irreversibility don't represent loss of heat. It represents what? Loss of work. Are you getting?
Yes. Yes.
Because suppose you are carrying out some kind of conversion of work, transformation of work only you are carrying out. You are suppose you are rotating some shaft. So in a generator, what we are giving? We are giving the shaft power, and
Yes.
what you are getting? You are getting the electrical
Electrical.
work, electrical energy. So
Yes.
both are work, both are work only. You are giving shaft work, and you are getting electrical work. Both are work, but in generator also there are reversibility. Are you
Yes.
getting?
Yes, sir. Yes,
Generator
sir.
में भी क्या है? There are
Yes.
irreversibility, and due
Yes,
to
sir.
that irreversibility, you will lose some work. So
Yes,
the
sir.
shaft work which is coming into the generator minus electrical work which you are getting, that difference is what the irreversibility loss of energy.
Irreversible. Yes, sir.
उसी को बोलते हैं exergy destruction. The loss of work, exergy
Yes, sir.
destruction, increase in unavailable energy, decrease in available energy. These all are the things which we can highlight as a irreversibility.
Yes, sir.
मैंने आपसे एक क्वेश्चन पूछा था तो उसको ये मत कि सर पॉसिबल नहीं है. इट इज पॉसिबल. इट इज वेरी इजीली simple process, huh? Like you heated the gas, then you remove some gas and you restore the system to the same initial pressure. So you leaked the gas in such a way that system will reach to the same initial pressure. That is possible. Technically, it is
Yes, sir.
possible,
Yes,
but
sir.
practically the process will be actually when you have not answered that question because even suppose you are answering and you are saying, sir, yes, we will leak and the way because when you are leaking the gas, the process will remain constant volume only because
Okay,
that is
sir.
the nature of gas. Gas is going to occupy the volume of the container. Whether there is 2 kg gas inside the container, whether it is 1 kg gas inside the container, or whether it is 100-gram gas inside the container, gas is
Okay,
going
sir.
to occupy the volume of the container. So volume
Yes.
will remain constant. Okay, so the process
Okay.
will follow the same path, but it will not be reversible, it will be irreversible. Because in that reversal process, the entropy of the universe is going to increase. That is the entropy of system
Okay.
plus surrounding. System will be zero, surrounding entropy is going to increase. And how
Okay.
you will find out the change in entropy of the surrounding? It will be minus Q by T
Minus Q by T
plus
plus Q by T.
no, plus mass
Mass
into S.
M naught S1. Yes, sir.
Yes.
Mass S1 minus mass S1.
For the
Yes.
idea, that will definitely come out positive.
Yes.
चलिए तो मेरे को ओवरऑल ठीक लगा स्पीच ड्यू टू टाइम लिमिटेशन आई एम एंडिंग दिस मोक दिस टाइम snap
Okay.
again if you feel you can join me let us see
Okay.
overall your presentation delivery skills are looking good okay there is no issue in that you are looking confident so एक बार और रिवाइज कर लो रिवाइज द एंटायर thermodynamics and again if you feel you can join me
Yes. Thank you.
ठीक है स्पीच ओके गुड
Thank you,
लक
sir. Thank you, sir.
बेस्ट लक फॉर योर इंटरव्यू
Thank you.